Hey team, so when we hear this phrase, similar figures, we're going to sort of dig into what that means. So, similar, right? We kind of hear that word a lot. It can mean the same, maybe not the exact same, not like congruent, right? But they're close, right? There's something kind of that is true for two or more of whatever it is that you are comparing. And figures can mean different things, right? But in this case, we're going to be thinking about sort of some polygons that we will be comparing. So similar figures, we can say they have the same shape to them, but what's different about them, what makes them not exactly the same, but instead similar, is that they're a different size. So when we kind of think about figures, we can know if they're similar if they're similar if the corresponding, so there's a vocab term, angles are congruent and the corresponding sides are proportional. So let's dig in a little bit to that. So corresponding angles are congruent. Well, congruent is a fancy math word for the same. So in other words, if we have these two triangles down here in this example, the corresponding angles that are congruent, we could say are the angles that are the same measure in our similar figures, right? In this case, similar triangles. So we know that E and B are corresponding angles because the marking, right, is one sort of single line like this, right? They are corresponding, they're the same measure angle. Similarly, corresponding sides are proportional in a similar figure. So if we think about the sides, right, the sides here are corresponding when they're touching the same two kind of angle pairs, right, that are congruent. So if we have angle B and this angle A, which has two lines, and over here we have D with two lines and E with one, right, then the side that is right here that is sharing angle A and angle B or touching them both will be proportional to this line here. Okay, so the measure of the corresponding sides are going to be proportional. So the ratio then of corresponding sides, what that's called is it's called the scale factor. Scale factor. All right. So if we kind of dig into that and we kind of do an example with these triangles here, we're going to use the triangles to answer the question. So first question is, are the triangles similar? And based on what we just explored, right, we know that B and E are corresponding angles. They're congruent. They're the same size, the same degree, as is D and A, and as is C and F, right, per their marks. So in that case, we know that this is a situation where the triangles are similar. So what we're going to do is we're going to give the corresponding angles. Okay, so the way that you can write this is so we can say angle A is not equal to, but similar to angle. Well, which one is the corresponding angle? Well, it's angle D in our second triangle, right? We could do that same thing for each of the angles. So we could say angle B is not equal to, but similar to angle, well, which one? Angle E. And you can do that for the last angle as well. Go ahead and make sure you do that in your notes. So we're then going to think about giving the corresponding sides and their relationship. Okay. So since we know that these corresponding sides are proportional, we can say that AB, the line segment AB, is proportional to DE, right? Which is the same equivalent proportion, right, in this triangle, in this figure of AC in purple to DF, as well as in yellow, CB to FE.